Good morning, everyone. I'm Dr. V.P. Anuja, Associate Professor of Mathematics, Arulmigu Palniyandavaru Arts College for Women, Chinnakalempur, Palani. Today we are going to see assignment problem. What is assignment problem? Assignment problem refers to special class of linear programming problems that involves determining the most efficient assignment of people to projects, salespeople to territories, contracts to bidders, and so on. It is often used to minimize the total cost or time of performing tasks. One important characteristic of assignment problems is that only one job is assigned to one machine. Hungarian algorithm. First, check whether the number of rows is equal to number of columns. If it is so, the assignment problem is said to be balanced. If it is not balanced, then it should be balanced before applying the algorithm. We use Hungarian algorithm to solve the assignment problem. First step, subtract the smallest cost element of each row from all the elements in the row of the given cost matrix. See that each row contains at least one zero. Step 2. Subtract the smallest cost element of each column from all the elements in the column of the resulting cost matrix obtained by step 1 and make sure each column contains at least one zero. Third step, examine the rows successively until a row with exactly one unmarked zero is found. Make an assignment to this single unmarked zero by encircling it. Cross all other zeros in the column of this encircled zero, as these will not be considered for any future assignment. Continue in this way until all the rows have been examined. Examine the column successively until a column with exactly one unmarked zero is found. Make an assignment to this single unmarked zero by encircling it and cross any other zero in its row. Continue until all the columns have been examined. Fourth step, if each row and each column contain exactly one encircled zero, then the current assignment is optimal. If at least one row or column is without an assignment, then go to step 5. Subtract the smallest cost element of each column from all the elements in the column of the resulting cost matrix obtained by step 1 and make sure each column contains at least one zero. Cover all the zeros by drawing a minimum number of straight lines as follows. Mark the rows that do not have assignment. Mark the columns that have zeros in marked rows. Mark the rows that have assignments in marked columns. Repeat B and C until no more marking is required. Draw lines through all unmarked rows and marked columns. If the number of these lines is equal to the order of the matrix, then it is an optimal solution. Otherwise, not. Sixth step, determine the smallest cost element not covered by the straight lines. Subtract this smallest cost element from all the uncovered elements and add this to all those elements which are lying in the intersection of these straight lines and do not change the remaining elements which lie on the straight lines. Repeat steps 1 and 6 until an optimum assignment is obtained. Let us see mathematical formulation of assignment problem. Consider an assignment problem as assigning n jobs to n machines. Cij be the unit cost of assigning ith machine to the jth job. Let xij is equal to 1 if jth job is assigned to ith machine. Xij is equal to 0 if jth job is not assigned to ith machine. Minimum z is equal to summation I is equal to 1, summation j is equal to 1, Cij, Xij, subject to the constraints, summation I is equal to 1, Xij is equal to 1, where j is equal to 1 to n, summation j is equal to 1 to n, Xij is equal to 1, where I is equal to 1 to n, Xij is equal to 0 or 1. This is the mathematical formulation of assignment problem. Okay, let us see an example. A job has 4 men available for work on 4 separate jobs. Only one man can work on any one job. The cost of assigning each man to each job is given in the following table. The objective is to assign men to jobs such that the total cost of assignment is minimum. First step, identify the minimum element in each row and subtract it from every element of that row. We have this table. Next, identify the minimum element in each column and subtract it from every element of that column. We get this table. Next step, make the assignment for the reduced matrix. Here we choose the 0, then cross the remaining zeros in that column and the row. In the second column, we choose this 0, cross other 0. In the third column, only 1 0, we assign this. Fourth column, no 0 is assigned because this row has already assigned a single 0. Here the optimality is not reached. So, we are going to draw the number of lines. Draw the minimum number of lines of vertical and horizontal lines using the algorithm. First, we mark the rows that do not have assignment. Next, mark the column that have zeros in the marked rows. Next, mark the rows that have assignment in marked columns. Now, we draw the lines through all the unmarked rows and marked columns. Here we cover all the zeros. Next, select the smallest element from all the uncovered elements. Subtract this smallest element from all the uncovered elements and add it to the elements which lie at the intersection of two lines. Here the smallest element is 1. We obtain another reduced matrix. Here we assign a single 0. We get assignment in each row and each column has single 0. Here the number of assignments is equal to number of rows. This is the optimum solution. The total cost assignment is 78. Okay, we are moving into another example. The given problem is balanced. 5 job and 5 men. 5 cross 5 matrix. Rows and columns are equal. So the given problem is balanced. First, we are choosing the smallest element of each row. From all the elements in the row of the given cost matrix, see that each row contains at least one zero. Next, subtract the smallest cost element of each column from all the elements in the column of the given cost matrix. See here, each column contains at least one zero. Next, we are assigning the zeros. Each row and each column having single zero. So, the current assignment is optimal. The optimal assignment is 1 to 2, 2 to 4, 3 to 1, 4 to 5, and 5 to 3. The optimum value is 86 hours. Then the third example is the given problem is not balanced assignment problem with the 3 men and 4 job. To convert the problem as balanced by adding a dummy row with zero cost, we have the following table. Next, subtract the smallest cost element of each row from all the elements in the row of the given cost matrix. Each row contains at least one zero. Next, assigning the zeros. We are having only 3 zeros. So, we mark the rows that do not have assignment. We mark the second row. The second row has no assignment. So, we first mark it. Then, we mark the column that have zeros in marked row. We mark the fourth column. Then, mark the row that have assignment in marked columns. So, we mark the first row. Next, we draw the lines through all the unmarked rows and marked columns. Determine the smallest cost element not covered by the lines. Subtract the smallest cost element from all the uncovered elements and add this to all those elements which are lying in the intersection of these straight lines, and do not change the remaining elements which lie on the straight lines. We are having this matrix. Now we assign the zeros. Each row and each column has single zero. So the current assignment is optimal solution. The optimum assignment is 1 to D, 2 to A, 3 to B, D to C. The optimum solution is 16. Thank you.